In this session 14 of our UTA classes, we are going to see exercises related to the thing we discussed in the last session, which was module 7. Module 7, we looked at application. The application there, we saw protocols. We saw the HTTP protocol, the SNMP, then the email protocols, POP, IMAP, MIME, SMTP, and we saw the file transfer protocols, FTP, Internet. Few features about each one. We had a discussion about the DNS, and this will come up in some of the questions that we're doing. And that's it. So let's get into today's session. So the application layer questions from this module, they may have some numerical type questions, but most of them are going to be your understanding type questions. So you will have to understand what the question is asking and put your perspective of what your understanding of that protocol is. Okay, but let's see some of the products. Question one. This question we have, if a DNS domain name is such, if you're given a domain name, how many labels and how many levels of hierarchy? So you might be tempted to say, okay, there's Voyager, FHDA, Edu, 3 labels, 3 hierarchies. But let's draw it. So if you remember in the previous class, we saw DNS trees like this, right? So we will need to draw something similar for this question also. So you'll have a root node, and then you'll have the edu node, and then you'll have FHDA node, and then finally variable places. So let me just label these. You have a root, edu, FHDA, void. And so actually, if you look, how many levels of hierarchy do you have? So that last one is also unknown. How many levels of hierarchy do you have? You have a root, edu, FHDA, and void. So actually, when we talk about hierarchies, you actually have 4. And what is the other thing that they have asked? Labels. Labels, root is not a label. Root is just a node that is at the start of every DNS tree. HU is a label, FHDA is a label, void is. And so label that is equal to this. So that is the answer for this question. So we have hierarchy, levels of hierarchy. Hierarchy is equal to 4, and levels of, not levels, labels, you have 3 labels. So they could give you a more complex website, and you would have to draw the DNS tree from the root, and each label in this will be a new node in the tree. Okay, let's move on. Now let's see some questions related to DNS. These are actually MCQ type questions. All are related, somewhat related to DNS domain name system. So let's solve these one by one. So the first question says, uh, okay, yeah, sorry. So in the first question we are given, a full domain's name is a sequence of labels separated by hyphens, commas, underscores, and dots. So just now in the previous question, we saw the domain name. What separates it? Dots. So whatever domain you have, abs.com, edu, you have domains, abs, Harvard, and edu, and these are always separated by dots, nothing else. IP addresses are separated by colons, but none of these other separation either. So the answer here is dots. Okay, next. The distribution of information in domain. So you're talking about something distributing in the domain namespace. Is achieved by using dash servers. So what kind of servers allows distribution of information? Is it DHCP, HTTP, DNS, or FTP? It's definitely not FTP because that's a file transfer protocol, or HTTP, which is an internet protocol. DHCP is a protocol that assigns automatic IP addresses to servers. So if you have servers in a network, if you have hosts in a network, DHCP is the protocol that will automatically assign, okay, this is so and so address, and this is also at so and so address. So that's still the name of the protocol, but here they're asking specifically for the servers. So the answer here is actually DNS. So we saw in yesterday's session also, DNS, you have a DNS client and a DNS server. And it is the DNS server that is responsible for distributing the domain names in the domain namespace. The domain namespace is the space of all domain names in the web. Okay, so that was the second question. Next, DNS is designed as a dash application. So what kind of application is DNS? Peer-to-peer, server only, client server, hybrid. We know so we just now we talked about DNS have server client architecture. So the answer is actually client server architecture. It's not a server only because there is a client. It's not a peer-to-peer. Peer-to-peer would mean that everyone in the protocol is equal. So all the servers are equal. Each of the hosts, they're able to share each other, the information to each other equally. But DNS server and client is not like that. There's a hierarchy. So the client has to relay the information to the server, get the information, and then relay it back. That's why it's client server. And it's not hybrid because there's only one type of application, that is client server. So C is the answer for this question. The C option. Okay, next. A host that needs to map an address to a name calls a DNS client called a dash. So we have a host. The host has an address and is trying to map that address to a name, right? And to do that, it calls a DNS client. What is the name of that DNS client? Is it tracker, resolver, converter, or mapper. It's not a tracker. So um tracker will not track the usage. Tracker, what it does is it tracks the usage of the information, the host. It will not map an address to a client. It's one of these. It's a resolver, a converter, or a mapper. And the answer is actually a resolver. So if you see, we would have mentioned the correct term yesterday also. Converting an address from a URL, from an address, from a name to an address or vice versa, that is what is called as DNS resolution. So a host that does DNS resolution is the DNS resolver, and it's not the converter or the mapper. So that is why in this one, in this question, the answer is B. Okay, let's move on to the next one. The next question says, to counter caching issues, DNS adds time to live values to map time to live value to mapping, defining the time in dash that the receiving server can cache information. So we have some time to live. Time to live is a timer that is set, and the packet can only live for that time. Once the time to live is over, for example, the time to live is 3 seconds, the packet is still not achieved what it needs in 3 seconds, and it will die. That's what time to live means. And so in a DNS server, what is the time to live in? And the options here is the time to live in minutes, hours, days, or seconds. So if you think about it, how long, what is the maximum you want a DNS server to be searching for information? We're not willing to wait actually for days or hours or even minutes to get a URL. So think when you search for something on the internet, when you search for it, hit enter, it tries for some time, and then if it fails, it gives you a failure message. So actually, here the answer is seconds, right? So the maximum that DNS will allow you, that the time to live value will allow is in seconds. So the answer for this one is D, seconds. Okay, these were a few MCQ questions on DNS. Let's move on. This is a little bit more theoretical question type of question. And the question is, it's all about HTTP. And it's asking what is the similarity between HTTP and www, SMTP, and FTP. So let's think about this. What is it? What is www? Www is actually World Wide Web. So what is the similarity between HTTP and www? www web is a web space. So it's a huge web space of different lots of information, lots of things in that web space. And what HTTP is doing is actually you have a host. Let's say this is your personal computer. You are accessing this HTTP. You're accessing this web space using HTTP. So that transfer of information from the HTTP from the web space to the host is done by HTTP. So let's write it down actually. So HTTP, what it does is a protocol that allows access to the World Wide Web. So that is the answer. So Both are related to the internet, but to access the World Wide Web, we need to use a protocol that is HTTP. Okay, let's move on to the next question. What about SMTP? What is the difference between, what is the similarity between HTTP and SMTP? So this actually has something to do with their uh, way. So if you look at what is SMTP, simple mail transfer protocol. So you have a mail that is SMTP, and then you have HTTP, which is web. So how can you find any similarity between these two? And actually, the similarity is in how these protocols operate. How does HTTP operate? So HTTP, you have a host, you have an HTTP client. So let me, you have your host, your machine, and you have the web, which you want to, and then you have an HTTP client. So I'm just going to write C, and you have a server S, and your connections move like this. How is it in mail? Do you have a server and client in mail? Yes. So mail also has mail server, mail client. And if you want to read your mail, your emails that you're getting, you need to connect to the mail client. The mail client receives mails that are sent from the mail server, which is able to see which messages have which destination and where they need to go. So that is the similarity between HTTP and SMTP. So let's write that. Both HTTP and SMTP use client server architecture. And what does this also mean? This also means that the messages are also similar because you send it's going from a client to a server. The messages from client to server are also similar. That's another similarity with HTTP. Why are they similar? Because they have the same architecture. They're doing the same thing. Okay. Final question. Uh, how is HTTP similar to FTP? What is FTP? File transfer protocol. So one is accessing web data. One is transferring files from one host to another host. What will be the similarity? If you think about it, HTTP is also actually a file transfer protocol. It's transferring files from the World Wide Web to your system for viewing. So in a way, the HTTP is also using file transfer protocol. But again, there's another bigger similarity between HTTP and FTP, and that is what protocol it uses to achieve this. What is important about FTP? It's a very important protocol because you're moving files from one place to another and you want those files to reach the destination. That means you want reliability. And when you want reliability, the best protocol that you can use is TCP. So that means the TCP connection has to be established between server from sender and destination, and then you can get reliable movement of data. So HTTP is also the same. It is also using a TCP transfer, a TCP service. This is different from DNS. DNS, if you remember, it uses a UDP service because DNS is trying to be fast. HTTP is trying to transfer the data as reliably as possible. So let's write it. Both HTTP and FTP use the services of TCP. And before that, we also mentioned, like you can see, HTTP and FTP are both for transferring files. So let's write HTTP. So also HTTP and FTP are used to transfer files. Are a protocol used to transfer files. Only thing HTTP is doing from web to your host and FTP is from host to host. Okay, that was this question. Okay, let's move on. Question 4. Let's see if we can find some more MCQ type questions. Okay, so we are given here for these are related to web pages and FTP also. Okay, so the first question says if the web pages or which to be retrieved are located on different servers. Okay, you have two servers where two different web pages need to be taken from. A new TCP connection needs to be created for retrieving each object. Okay, this method is referred to as a dash. So you have a file here, you have a file here. For each file, we are making a separate connection. So what is that type of a connection called? Persistent, non-persistent, continuous, or dynamic? So what is the meaning of persistent actually? Persistent means it persists. So you have a single connection that is always there, and all the files use that single path, that single roadway for their communication purpose. That is what a persistent connection is. A non-persistent means that that single path does not exist. So I think you're seeing now how the answer is actually non-persistent. So you do not have a single persistent path, persistent connection. Instead, you have connections that are changing as per requirement. That's such a not persistent. It's not a continuous. It's not continuous. It's actually breaking it. It's not dynamic because every time there's a new one, there's a new thing being made. It's not being made dynamically. But if it was dynamic, you would have it would create a connection for the new one, then remove it, and then a new one, it will create another one. But that's not what is happening, right? So that is this question. Okay, let's move on to the next question. The contents of the cookie are never read by the browser or disclosed to the user. It is a cookie made by the server, and it. Okay, so there's no blank actually in this question. Uh, okay, so I think it is meant to be that it's hidden, that it's but this is still an important like point to remember. Cookies are server side objects because they are not ever read by the browser does not get to see them. The user also does not get to see them. The only people who can read the cookie is the server. Okay, that's fine. Let's move on to the next. The status Status code field in the response message defines the status of the request. Consists of 3 digits. We saw this 3-digit codes yesterday. Codes in the range 200 indicate a dash. So let's go back actually to yesterday's session. We saw the codes here. Well, that time we had discussed 200 was success. 200 success actually comes under the class of successful class, successful status codes. So here our options are failed, unsuccessful, successful, penned. So it's successful. Failed and unsuccessful, those both are wrong. Those are the same thing. It's not pending either. The type of classes that we have here, we have that's information, redirect, client error, server error. We don't have anything to show that, oh, this is still pending. That's why the correct option for this is C. Okay, next question. The control connection in FTP remains connected during the entire FTP session, while the data connection is open and closed for each dash activity. So the data connection in FTP, when is it open and closed? File transfer, file retrieval, data transfer, file transfer, and connection. It's file transfer. So this is the file transfer protocol. How it works is every time you have a file connection, every time you have a file that needs to be transferred, it'll open a data connection. It's not connection because in file FTP, connection is not changed. It's written here. Control connection remains connected during the entire interactive FTP session. So that connection will remain the same, but the data connection, which is transferring the data, transferring the files, that is what will keep changing. So data transfer, file retrieval, file transfer is the more appropriate wording. So that is the answer. Option C. Okay, let's move on. There's one question, theoretical question. I'll paste another one now. This is another question. Okay. The question is, can a query message have one question section, but the corresponding response message have another section? So where are we talking about query and responses? It's here, where you have an operation and a status. So the question actually become, can an operation have more than one status? Is it possible? Can it have a success and a client and an error? Can it have a redirect and an error? So you'll see actually you cannot have, right? So the question here says, if you have one question section and one response section, can you have several answer sections? If you have one question section, can you have several answer sections? The answer here is actually no. One question section, needs only one answer. What is this type of relation called? When you need one, when every question section needs one answer. It's called a it's called a one-to-one relation. So one-to-one relation is present between question and answer sections. So that is this answer. So it's not possible to have. So here answer no, and here's the longer answer. Okay, let's move on to the next theoretical question. Okay, question says to find the IP address of a destination, we need the service of DNS. Right? If you want, we have a name, you want to find the IP address, you need DNS. Correct. DNS needs the service of UDP or TCP. Right? We show that DNS is working on UDP. UDP or TCP needs a service of IP, right? But IP needs an IP destination address, which we are trying to find. Is this a vicious cycle? So what they're saying is, have IP. To find IP, you need DNS. So this one B. To find DNS, you need UDP. Or UDP, you need the service of IP, which needs I. So you're not able to find anything else. So how is this cycle avoided or is it avoided or is it not avoided in the DNS protocol, the DNS service? So the answer is actually it's not going to be a vicious cycle. Obviously, it's not going to be a vicious cycle because this is how we are able to get DNS done. And the reason is if a particular host wants the IP address of its destination, let's say you have a sender A and a sender B, and A wants to send a send to B, and A needs the destination of B. So it needs an IP address of B. But when it sends a packet, that packet which it sends will already have in the IP section itself, it will have the destination address of B. So what I'm saying is the IP address is not dependent on another service. So let's think of it this way. Let's think of it backwards. Let's say if B gets a message from A and B gets a message of A, will it need DNS and UDP and IP to get the address of A back? No, because in that message itself, the address of A is also mentioned. When A is sending a packet to B, when A is sending a packet to B, the message that it sends will already include the address of A. And you don't need any DNS or UDP, you only need IP. And the IP data field, that itself contains the answer. So how would you write this out as properly? So no, a cycle is not formed, right? If if let's say host A needs if host A needs host B's IP address, where will that information be? That information will be will already be present. That info will be present in the IP data field. Right? The IP field, so the destination address field in IP will have the address. So DNS is required once you get the IP address, but a cycle is not found here. DNS is required to get the IP address. It will send that UDP, it will find the host. That host will be used, and then that data field will have the IP address. And so when the internet protocol is not, when the input protocol needs an address, it does not need to depend. You can just look at its IP data field. Okay, so this was a question that is a little bit more theoretical. We saw this question. This one was, you have to remember. So remember that in query messages, one question corresponds to one answer. Then we saw all these questions about cookies, HTTP, how FTP works, how HTTP works. Then we saw similarities between HTTP and some other protocols, which you may think there is nothing similar, but there is something. Maybe how it is working or what protocol it is using based on that. Then you have these are questions related to DNS, how it's separated, what server, client server, everything, DNS resolver, the term, and how long a DNS time to live will be. And then first we had seen this question where they had given us labels. They gave us a domain, Voyager or FHDA.w. They asked how many labels and how many hierarchies. And we found once whenever you get this kind of question, if you can draw a DNS tree, that will show you how many hierarchies. And labels you can directly count from the domains. So edu, FHDA, and so in general, hierarchy is equal to label plus one. Labels plus one. And labels is equal to dots plus one. So like you have two separators here, two dots, so you have three labels that it separates. And the hierarchies, once you count the labels, so here you have three labels, hierarchies, all you have to do is you have to add one. So 3 plus 1, you'll get 4. Okay, so that's all the time that we have in this session. We looked at application protocol in this section. We looked at the domains, the types of protocols. There's how they have been improved, the different versions. DNS, the types of messages we had seen in the previous section. Parts of DNS, who registers the DNS. In file transfer, we saw the commands and how it's made secure. And finally, in today's session, we saw some questions related to application layer protocol. Okay, that is all for this session. See you in the next.